on day 2 to talk about the build pipelines and releases. Today we're going to be working with Ben Thompson, who is our resident cloud architect and DevOps engineer. Works very closely with Azure DevOps. So he'll be leading off today with that walkthrough. So if everybody's really excited. Yesterday we talked about work items, some of that work item tracking, be able to customize the process, being able to do some portfolio planning, forecasting. There's a lot to take in, and today's going to be no different. There's going to be a lot to go over to, that Ben's going to be discussing with the pipelines, a lot of different techniques and the technology that gets used there. So what we're going to be doing is at the end of this session, we're going to open up for a Q&A session. So I hope everybody can hang out. We'll only do it for a few minutes. So please queue up your questions. If you didn't do so much yesterday, but at least today, if you queue up your questions, we'll definitely answer them towards the end. And feel free to ask questions during the session. I'll be in the background to answer any questions as Ben is presenting, as well as Gina and Ryan will be there too. So we'll be able to field anything that you may have. If you want to wait until the end, that's fine too. So please queue up your questions. And then at the end, we're going to have a survey. So if everybody can hang out as well. And again, just a little bit more, just to fill out a quick survey. It's not long. It's just more information about like how you guys think we did during this event. What, if we were to do this again, what else would you want to see? Just to give you a kind of a heads up is, you're going to be good for all of you here. Going to be the first to hear this. We're actually going to start to spin this off into other deeper dive aspects of Azure DevOps and pipelines using just DevOps technology in general. As we are all starting to mature a little bit more with DevOps methodology, it's time to start doing some deeper dives into these things. So we're going to be spinning off a lot of other type webinars like this. So if there's something you really want to see, let us know in the survey. All right. So, and then you'll be also, as for everybody that fills out the survey, you'll be entered to win a $25 Starbucks gift card, which is kind of timely considering a lot of our states are starting to reopen. So please, like I said, hang out and we'll make sure you get entered for that. All right. So with that said, without further ado, Ben, please take it away.
Hi, everyone. I'm Ben Thompson. I'm a cloud architect with Talon. To follow on to what Gerard was saying, I would just like to make 2 additional notes. If you do have questions during the session, please put them into the chat window in Teams, and Gerard, Gina, and Ryan will answer them from there. And we are also recording this meeting just like we were yesterday. All right. So like Gerard was saying, he covered the boards and the test plans feature of DevOps yesterday. And that was very good from a project management perspective, exploring some of the agile methodologies that we can use as a part of DevOps, and some of the testing tools that we can use to ensure that our code is fully tested and has gone through a QA cycle before being deployed. Today, I will be focusing first on Azure Repos, which is the source control part of Azure DevOps. And then after that, we will take a look at Azure Pipelines, which is the CI/CD platform. To go a little more into detail, and I'm going to keep this brief because we are going to be doing a demo for most of today. Repos is the source control part of DevOps. It's probably the part that's going to be most familiar to everybody, regardless of if you're coming from TFS, if you're coming from GitLab or any other source control solution, because it's either Git and it has all of the features that you would expect for a Git source control repository, or if you're coming from TFS, you can use the TFS version control that has been part of that product for since the beginning. So both options exist inside of Repos. Obviously, Microsoft is pushing more towards Git going forward, but there is still full support for TFVC, just like there has been in TFS. And even then, there's additional features on top of that that if you're coming from TFS 2015 or earlier, you probably don't have right now. The next thing we're going to take a look at, Azure Pipelines, is a full-featured continuous integration and continuous deployment platform. So it supports a wide variety of languages just right out of the box. Listed here, we have Node.js, Python, obviously C#, any of the .NET languages. You can also build iOS apps because it supports running builds on Mac OS. And a nice thing that we'll see about pipelines is you don't even have to run your own build agents. You can use Azure Pipelines, Microsoft hosted build agents to run your builds, run your deployments, and you don't have to maintain any hardware yourself to get your code built and deployed. So that's really great, and that really helps speed things along, especially if you're a smaller organization. You don't really have the will to set up a bunch of servers that you don't need to run your code. You just need to build it. So that's really helpful there. And let's not waste time. Let's get to the demo. So I'm going to be using the same team project in DevOps that Gerard was using yesterday. So we have the same work items, same everything in here. But now we're going to take a look at this repos section in here. And I actually have a sample repository that Microsoft provides. It's basically like a best standards for .NET Core, ASP.NET Core development. It's called eShop on Web. And if you Google it, you can find it. All I've done is I've pulled it into this DevOps project and made a couple changes to it that we'll see as we go forward. So repos in general, this is Git. So we have all of the files in here. It shows README files down here. It's very helpful if you have some information, like when you go on GitHub and you just see a high-level overview of the project and how to run it. So that's very useful. Any other features you would expect in Git are here. There is a full history on everything that you can view right from the web browser. You can compare different branches. You can do an annotate on each file. And there's additional features that we'll get into as we go a little further, such as pull requests, which are really a big part of the Git workflow. And if you need to, and it's not really something you do often, there's also a full file editor in here, so you can make changes and commit them as part of the website as well. So this is the file view of the repo. You can see, commits, pushes, all the standard stuff. You can see all of the branches that have been pushed up to the server. One thing that's nice about DevOps, a nice feature, is that you can set security on each branch. So right now we just have pretty much everybody allowed to push to the master branch, but you can lock that down, and you can lock any of the branches down in that way as well, or a folder. And what I actually have set up on the master branch is what they call branch policies. And these are really what enforce the pull request workflow that we use in Git. So we can require a minimum number of reviewers as part of a pull request. Normally, you wouldn't allow someone to approve their own changes, but because I'm running the show today, I just have that checked off. And then there's a bunch of other options in here. If you keep your work items in DevOps in the boards, you can check that every single pull request is linked to a work item. And I'm actually going to change that to required right now. So if a pull request doesn't have a work item on it, we can't complete that pull request. Some other options are limiting merge types. So if your team has a certain type of merging that they want to use with Git, you can enforce the use of that type of merge. For teams that aren't very familiar with Git, what we normally do is disable everything except the basic merge, just because that's the most straightforward if you're coming from a type of source control that isn't as branch centric as Git, something like TFS. You can also integrate with other third-party services. And then something that we'll add in a little later once we create a build pipeline is a build policy. So what that does is whenever we create a pull request, that will actually run a build against the code. It'll do a test merge of our code into the master branch and run a build on that code. And if it fails in the build step, if any of the unit tests fail, anything like that, it blocks the pull request from being merged into master. The final thing that we have in here is adding in reviewers automatically. So right now I have it so that myself and Gerard are added to every single pull request. But you also have the option of setting different automatic reviewers for different folders. So if if you have certain people who are subject area experts on certain parts of the application, you can have those people automatically added to pull requests only for changes that affect those parts of the application. So these are some of the features that we have as part of repos. And we'll be back here a little later once we build out some of our pipelines. All right, and oops, I do have to save my change. Let me just make sure. Yeah, because I changed this to required. All right, so pipelines is where we're actually going to be spending most of the day today. So pipelines, like I said before, this is where we develop our CI and CD to build our code every time somebody commits a new change, and every time a build is successful, we will deploy that code out to our development environment. So there are two different ways to create pipelines in Azure DevOps. There's what they're calling the classic method, and let me just show that. So there's the classic editor, which is a visual editor, and then there is YAML, which is a text-based format. If you're familiar with something like Jenkins or older versions of TFS, all of that is text-based when you create your build definitions. So that's really what the YAML is, and that is the really, it seems that's where Microsoft is pushing everybody to go to. However, the classic editor is still supported, and that's actually what we're going to take a look at first. So I'm going to use the classic editor. So we choose our team project that we want to build from. We do have multiple Git repositories, so I'm going to make sure to choose the eShop one. And we are going to use the master branch as our default branch. Now you can run builds across multiple branches. This is just saying that, when I queue up a new build, it's going to default to choosing the master branch. And DevOps comes with a ton of templates for different types of applications. So this is an ASP.NET Core website, so I'm going to choose that option. But there's also options for Azure Functions, even things like Go or Xamarin. So these are great starting points. Most of the time, you'll have to make a couple modifications depending on what else your application needs to build. But we'll start off here and make changes as necessary. So this is the classic editor. So you can see it's fully visual. We have a list of steps on the left-hand side, and for every step, there is a list of properties on the right-hand side. And when the build runs, it basically goes top to bottom. So, and you can have multiple agent jobs. In this case, we only have one. So it'll run the restore step, and then the build step, test, publish artifact in that order. And if the test step fails, maybe because one of our unit tests fail, it won't go on to the other steps. It stops here and the whole build fails. So first thing I'm going to do is rename my build to eShop build. And then on the pipeline tab here, we have a couple extra settings. So agent pool is where we decide, do we want to use one of the Microsoft hosted build agents, or do we want to provide our own build agent? So most of the time for normal applications, especially if you're deploying out to the cloud, you can get away with using the Microsoft hosted build agents. And if that's the case, they're really the better option just because there's a lot less for you to manage infrastructure wise. And we can choose from different types of build agents. So there's Linux, Mac OS if you want to build an iPhone application, and several versions of Visual Studio. So I'm going to choose Windows 2019. That comes with Visual Studio 2019. Which is what the application is built with. If you have a situation where you need software packages installed that aren't available on DevOps or that you can't install on the Microsoft hosted build agent, that's one situation where you might need to look into using your own build agent because you would be able to install those on your own machine that you manage. Another situation is if you need to do a deployment and your server that you are deploying to is behind a firewall and you don't really want to open that up to DevOps, which runs out on the open internet, you can create a build agent that runs behind your firewall and use that to do your deployments to your internal resources. So those are really the two main situations where you would want to use your own build agent. All right, so the next thing that we're going to do is update these parameters here. So parameters are basically things that we can reuse across multiple steps. So you can see here we have the project that we want to restore and build, and obviously that gets used across multiple steps. And then we also have the project that contains our unit tests. So we'll use that as well. All right, so let's take a look at our different steps here. So these are all using the .NET Core task type. It's just different commands on that. So the first thing that we do is restore our NuGet packages. Then we're going to run our actual build. The next thing we want to do is, once the build is complete, run our unit tests. And let me make a little change in here. So if we add in this -- collect code coverage, this is actually going to create a code coverage file based off of the pieces of code that our unit test hits. And we'll take a look at that after this build is done. The publish step will take our DLL, take our website artifacts, images, JavaScript, things like that, and compile it into a single zip file. And that's what we're going to be deploying out to our web server at the end. The last step, publish artifact, will take everything in this artifact staging directory and send it back to Azure Pipelines. And what that does is that retains it so that we can take a look at that build and see what the output was. And it also lets us use it as part of a release to copy it over to our web server. I do need to add one more step in here for copy files. And we'll get into in a little bit what we need this for. But this is what we're going to use to actually do our infrastructure as code and deploy and so we're going to be deploying this website out to Azure. So this file here is the ARM template, and I'll show that in a little bit, that contains the definition for the different types of resources that we need in our Azure environment. So now that we have all these steps here, we can take a look at triggers at the top. So the main trigger that I find is used most of the time is the continuous integration trigger. So when we enable this, any commits to the master branch or merges into the master branch after a pull request are going to cause this build to be kicked off. And another option on here is batch changes while the build is in progress. This one is really dependent on what you want to do. If you batch changes together, that means that when a build is running, if 3 more commits come in, there's only going to be 1 more build that contains those 3 commits. If it's unchecked, then you're going to get a new build for each one of those 3 commits. So it really depends on what you're looking to do. If you keep it unchecked, then you'll know exactly which commit broke the build if one of them breaks the build. If you keep it checked, then your latest build will reflect the latest code more quickly. You don't need to wait for 2 new builds that you're basically going to throw away before you get that 3rd one out there. So when I'm working, in a smaller group, I normally just keep it checked. That way, we don't waste time if we want to get a new build out to the dev website. You can also schedule a build. So you can run a nightly build if you only want to do a build every night, whether you're trying to save time and not run builds all day long and only run one a day. This is really up to you if you want to do a schedule. All right, and then we also have the option to do things, change things like the build number format. We can only link work for specific branches, stuff like that. And then there's also a history of the build. We can look back and see what was changed over time as people come into this interface and make changes to it. So for now, I'm going to save this build. So we named it, so we're good there. And now that it's saved, I'm going to queue it up. So we'll keep our defaults here and click run. So this interface here is the interface that is going to show our build running. So there's only a couple things on here right now, but we'll get more information as the build progresses. So we can see the branch that this is coming from, the repository, and the commit number that's associated with this build. We can see, when it was ran, what work items are related to this build. So this is kind of interesting. So the latest user story that I added to a to a commit is this one here, to add a version number to the website. So it picks up on that because that work item wasn't a part of any other builds so far. We can also see changes since the last build. This isn't very useful for the first build of this pipeline, but as it progresses, if we only change one file or make one commit, we can see that here as well. Taking a look at the actual job is where we can see what the build agent is doing. So we see that DevOps added in this first step, check out the master branch, just pull down the source code. Now it's running through the NuGet restore. And this one can actually take a little while depending on how many packages you have. And since it's pulling from the public NuGet repository, sometimes that's a little slower. But for this site, I think we'll expect about 1.5 minutes here. Once the log's complete, you can also view the raw log if you want to just save it to a file afterwards. Maybe you want to save it and go through it in more detail in a text editor to look for certain issues or anything like that. You can also search through it. So if I want to search for, just Control F's through it. This interface is pretty nice though, because you get all the output from the build agent right here on the screen, tied right to the build without having to really search for it. So right now it's doing the build. That should be done soon. Then it's going to run our tests and do our publish. So while this is going, I'm going to show what the ARM template looks like. So let me pull up Visual Studio. So the ARM template is basically, it's what's called infrastructure as code. And the idea behind that is that instead of having someone from the IT team or the development team go into, in our case, Azure, and click around and create, I need an app server, I need a database, let me click around and manually configure all of this stuff. We can document the desired resources and configuration into a file or set of files and deploy that out to the Azure resource group that we want our application hosted in. And then Azure takes that file, parses through it, and determines what resources we need, what configuration they need, if we need any changes. And it really does all the hard work for us. And one of the great benefits of that is that if you have multiple environments, you can deploy the same template out to each environment, and you only have to change things like name or names of resources or the scale or how big the VM is, stuff like that. So taking a look at the ARM template, there's a couple different sections in here. The first section is parameters. So these are variables that you can set when you deploy this ARM template out to Azure. So we have things like the name of the environment. So is it the dev environment or the prod environment? The base name of the resources. In this case, it's my initials and then eShop. The DB account for the SQL server. So we have a default username in here, but the password needs to be passed in as a secure string whenever we deploy this ARM template. After parameters, we have variables. These are either constants, as we see here, or calculated values that we are going to be using lower in the script. And this lets us, kind of encapsulate that up here, so we don't need to, do this concatenation every time we want the name of the database. The final section is resources. So this is where we actually describe what resources we want to be deployed out to Azure. So the first thing that we need for this website is a SQL Server database. So we are pulling the name from up above. The type we are saying is Microsoft.SQL/servers. And then this and all of these parameters here, you can look up. There's an ARM template reference that Microsoft has published, or if you go into Azure, you can export the template from an existing resource and kind of pull that into your own template. And so inside the SQL Server, we're creating two databases, one for the catalog of items that we're displaying as part of our eShop, and the second is for the identity, so that's users, logins, and passwords. After we create our SQL Server, the next thing we need to do is create the web server. So this part here, we're creating the server itself. For the SKU, we're choosing the free option, so this doesn't cost us anything. And the next part is creating the actual website on that server. So if you're familiar with IIS, then this is called an app service plan in Azure, but here, Server Farms, it's basically the VM that's hosting IIS. And Microsoft manages that VM for us, so all we need to do is deploy the actual websites out to that. And we can determine which resources depend on each other. So the website itself depends on the web server existing. So Azure will deploy out the web server first before it puts this website on it. And it also depends on the SQL Server being out there because we are using that as one of our connection strings. So this is actually something that's kind of nice. As part of this template, our connection string for the catalog database and the identity database are automatically being updated to contain the password and the username that we pass in for the database. Obviously, in a real environment, you wouldn't use the dbadmin user to run your web app. But in this scenario, this is just a simple version of that. In Azure, you can also use Azure AD authentication, in which case you wouldn't have any credentials in here at all. But that's a more advanced topic. And that's it. That's all we need to run our application. So that's all that's included in the ARM template. Switching back, I don't know what happened there. We'll see about refreshing the page. All right, so our job is now done. If we look at the test step, all tests passed, all 47 tests. And once we're back here on the main page, there's a couple new things on here. The first that I want to show is one published. So this is actually related to our artifact that we publish at the end of the build. So if we look at this, we can actually see what files we're outputting as part of that. So this is the ARM template from that copy file step. And this is the website zip file that we created as part of the build. The next thing is that we have a dashboard to view all of the unit tests that ran. So in our case, they all succeeded. So let me put that here. And we can actually look through all of our unit tests. If one fails, we can get the error message out of it. And most of the time, there will actually be a link in the stack trace to the repos section to bring us to the actual file where the exception was thrown. So that's nice. And this can be tied down to test plans as well if you're doing automated stuff down there. Code coverage is the next thing I'm going to show. So you can, there's a way to configure it to show a code coverage report on this page. I haven't done that as part of this build just to keep it simple. But what we can do is download the results file to our computer and open that up in Visual Studio. And I believe this is only a feature of Visual Studio Enterprise. All right, so when we take a look at code coverage, it gives us the covered and not covered percentages and blocks. A block is basically anything in C# anyway, anything between curly braces, more or less. So if you have an if-else statement, the if portion is one block and the else statement is another block. And code coverage will actually tell us if we are only hitting the if in all of our unit tests and we're not hitting the else. So as you can see, our total coverage is only 14%, so that's not great. But we can actually dig in and see which files and namespaces are more covered. So we really get a good idea of where we want to direct our unit testing efforts. So I can come in here and I can take a look. So this one, everything in this file was covered by a unit test, which is it's kind of not a great color on this color scheme, but the blue means that the unit test hit that. And if we take a look at one that isn't covered, so in this case, red means that no unit test hit this code block here. So this could be because the unit test always had orders come back as an empty array, right? So it would never hit this select code in here. So code coverage is a great way to get an idea of how your unit tests are in hitting different parts of your code. So this example here is a great one. Without code coverage, you probably wouldn't realize that you weren't testing any of this code in here, because you know that you test this method, but you aren't testing every branch inside of it. The goal of code coverage isn't always to get 100% code coverage. That would be great, but it's kind of a low-hanging fruit type of situation. You want to get it definitely higher than 14%, but if you're at 90% code coverage, that's great. So don't feel like you need to always hit 100% code coverage, especially if there's code that maybe doesn't need to be tested. And I don't know exactly where. So like in this case, do you really need to test the get and the set of every property? Probably not. Do you want to test your logic like over here? Definitely. So code coverage is a good metric. It gives you good places to look, but it's not the end all be all of testing. All right, so the last thing that we are going to change as a result of this build existing now is our branch policy. So we can come back into branches, go to the master branch, and create a branch policy. Well, we already have one. We're creating a build policy. So we select our build pipeline. In our case, it is eShop build. And we are going to do automatic. And we are going to require that the build is successful in order to complete our pull request. The option down here for build expiration. So this is going to depend on your organization and how quickly, how many pull requests you have going on at one time, how quickly new code is making it into the master branch. So the idea here is that if it's immediately, then if you have two people doing pull requests and person A completes theirs first, the build for person B's pull request is invalidated. So that means they have to run their build again, wait a couple minutes, and then they can complete their pull request. If you have, so that's fine if there's a low volume of new code being put into master, because then you're sure that no matter what, when code is merged into master, the build succeeds. If you have a high volume of code being merged into master, you might find that some people are sitting there for quite a while waiting for their pull request to make it into master, because every time they are about to finish it, someone else finishes theirs first, so they have to rerun the build. And especially if your build is longer than a couple minutes, this could be an issue. So you can say that as long as your build succeeded within the last 4 hours, even if master has been updated, you can merge your pull request in. So it's really going to depend on that. So I'm going to save this, and I believe that automatically saves it. Yeah, so we don't have to save the whole form. All right, and we'll see this whole pull request workflow in a little bit. The next thing I want to do though is actually create our release pipeline. So whereas the build pipeline, at least in the classic methodology, is only focused on taking your source code and artifacts and building them together, compiling them, and producing an output, the release pipeline is concerned with consuming the build artifacts, the output of the build pipeline, and sending that somewhere. That could be, in our case, as in our case, a web app out in Azure. It could also be a VM. It could be a Docker or Kubernetes cluster. It could be machines you have on premises. All of these are supported through the DevOps release pipelines. So what we're going to do is create a new pipeline, new release pipeline. Nope, sorry, that's not it. Over here, so we're going to create a new release pipeline. And we are going to use the Azure App Service template. All right, so this is the view for the release pipeline. You can see on the left-hand side, we can add in artifacts. And then on the right-hand side, we define stages. So each stage normally corresponds to a certain environment. So our first stage will be the development environment. After that, in our example, we're going to be going straight to production. But you would normally have at least a staging environment in between and potentially a test environment, training environment. Those are all different things that you might want in there. And I'm going to rename this quickly as well. All right, so the first thing we want to do is add in a new artifact. And you can see there's a bunch of different places we can pull these artifacts from. We can pull it straight from our Git repository or TFS. We can use Azure Artifacts, which is basically, you can use it as a NuGet repository, NPM, something like that. We can pull from GitHub. We can even pull from Jenkins. We are going to stick with our build pipeline. And all we need to do is choose that. We have a couple options down here, the default version, source alias. We'll just leave those as the defaults for now. The next thing that we want to do is enable our continuous deployment trigger. So what this does is whenever the eShop build is successful, it's going to kick off a new eShop release pipeline. And I'm just going to add in a branch filter here because I don't ever want to deploy anything out to dev or production that didn't come from the master branch. All right. The next thing I'm going to turn on quickly is under options. I am going to report deployment status to boards. What this does is when we hit the dev stage and do that deployment, it's going to go back to our boards, and whatever work items were associated with that build, it's going to associate this release with those work items. And that way we have visibility into when and where a work item has been released to. There's also integration with Jira if you want to use, and that kind of goes back to how we can use different parts of DevOps piecemeal if we want to integrate, maybe pipelines into our Jira and maybe GitLab, and we only want to use the pipelines feature of DevOps. That's an option. The next thing we're going to do is define a variable here. So what we need here is a variable for the database admin password. And we're going to use this for that ARM template. Let me go back to that. So one of our parameters in here was the database admin password, which is a secure string, and that has to be passed in to the ARM template by whoever's deploying it. In our case, that is this release pipeline. So we do have to put the password in here. There are other options. In our case, we're just going to put it in here. But we can use a secure password here, which means that it's going to store it in a secure location. It's not going to keep it, in plain text as part of this releases definition. So let me just put that in there. And we're going to change the scope to the dev stage. So that this will let us have a different password for our dev environment and our production environment. All right, so now back on the pipeline, we see an exclamation point here because we have to make some changes to the configuration of this stage. So if we come into here, we can see, what the issue is. So we have to select an Azure subscription. And how the subscriptions and connections are managed are with these service connections. So I already have one set up here to my Azure environment, but this is normally this is something that IT is going to have to set up because it involves making some changes to the Azure environment. All right, so I put that there. The app service name is going to be EDT shop web-dev. And this is used in our deploy Azure app service step. So it knows which app service to deploy this out to. The other change that we want to make for the agent is to use Visual Studio or Windows 2019 just to match up with our build pipeline. And now we need to add a new step to deploy out that ARM template before we do the app service deployment. So like I said, we want the template to be deployed out first because otherwise there's nowhere for us to deploy our website to. So again, we're going to choose the subscription or the service connection, and then in here, the subscription. We're going to create or update a resource group. The resource group does not exist yet, so we are going to name it eShopDevRG. For location, I'm going to choose East US 2. And then the actual template, that was part of our build artifact. So let me just open that up right here. And then for override template parameters, this is where we can override any of the defaults that were specified in that template. In our case, the only one that we need to do right now is the database admin password. So I just put that in there. This syntax here, the $ in parentheses, is how you access variables, and that goes across any of the different types of pipelines. So your variables that you define are just the name of the variable. Sometimes Azure has built-in variables, so that might be something like the artifact staging directory. And in that case, it has the build as a prefix to it. In our case, this is our variable, so it's just the name of it. All right, and now I'm going to save this. Every time you make a change, it is outside of your repository, but we can add a comment to it. So added stage to release. All right, so now we have our dev deployment here. The next thing I want to do is add in my production environment. So since I want to do the same steps pretty much, all I have to do is come here and click clone, and it creates a copy of that stage. So I'm just going to name this one prod. And the other thing I have to do here is come in here, and it knows that we had this variable for dev. So when it clones, it gives us the same field for prod. So let me put a password in here. And we also, if we look back at our ARM template, there is an environment parameter. So we need to set this to prod because the default is dev. So let me add in environment prod, and that only applies to the prod stage. All right, so now I'm going to come into that prod stage and make a couple changes to our tasks in here. First thing is that instead of dev, the name of it is now prod for the app service. In the template, we want to deploy it to the prod resource group. And we also have to add in a new parameter override for the environment variable in our ARM template. So we put that right there. And that should be it. So now if we take a look at our pipeline again, We have our eShop build. Once that succeeds, we have the continuous deployment trigger, and that kicks off our dev build. Once that succeeds, we kick off our production build. However, we don't really want the production build to happen right after the dev build. We want some kind of, pause in between, because, that's the point of having two environments, is that they can have different things on them. So to do that, we add in a pre-deployment condition. So there's two main ways to do that. The first is pre-deployment approvals. This is a manual process. This is where a person comes in and says, yes, I'm ready for this deployment to go ahead to this environment. A gate is an automated way to do it. So a gate, there's a couple options here. We aren't actually going to use them today, but you can evaluate something in Azure Policy, which is a governance capability built into Azure. You can call in Azure Function, which is a serverless compute technology in Azure. So you can write some code in there that would, check the state of something, if it's approved or not, or, your environment's up and ready to go. You can hit any generic REST API. You can integrate with something like, ServiceNow or, something like that. You can query work items, make sure that, as part of this build, there's no bugs that came out of your QA cycle if you do QA on your dev environment, or if you had a QA environment in here. So the gates are a great way to do automatic evaluation of certain conditions before your deployment goes ahead. What we're going to use today is pre-deployment approvals. So in here, what I can do is I can add in one or more people, and we can say that either all of these people have to approve it or just one person has to approve it. Yeah, so in this case, when we get to this stage and we're about to deploy production, Azure will send out an email to myself and Gerard asking us to come in and approve this deployment. And we'll take a look at that in a second as well. So now that we have our dev environment and our production environment, let's actually create this release and have it go through. All right, so I saved it, and I come in here, and I'm going to create a new release. Normally it would get kicked off by a build, but because we created this release after the build already finished, there's nothing that's going to come out of that. So I'm just going to create it manually. And it's going to be based on our latest version of the build. All right, so now we can see our release has been created. We can click on that to view the operational or release focused view. It looks very similar to the one where we're editing it, except we actually see stuff filled in now. So we can see which build version and which branch the build or the release is pulling in. We can see who kicked off the release. In this case, I triggered it manually. If this was part of a continuous deployment, then that would show up here as well, or if it was scheduled. All right, we can take a look at the actual logs coming out of this release. So it's going pretty quick. It's in the ARM template deployment right now. So it connected to Azure. It found that the resource group does not exist. So it's creating the resource group, and now it's deploying out those resources. Like I said before, there is the SQL Server database server, the two databases on it, and then the web server and website. So it's actually going through this ARM template, combining it with the parameters we passed in, like the database password, and deploying out all of these resources to Azure. And I actually have Azure pulled up, and we can see our new resource group got created. And we can watch the deployment go on here as well. So we can see it already created the app service plan. That's probably the fastest one to create. If I come into deployments, I can see its current status in creating all of the things. So it created the database server, created the web server already, set the firewall rules on the database. Looks like the website actually made it out okay. And now it's just the two databases that are taking a little while. So we're going to wait for this to complete. because then we can actually take a look and make sure our website is out there and running okay. Should be done very shortly. Looks like the identity database is now done. So let's take a look down here. So, all right, we're still waiting on this deployment. And we can see over here everything that was passed in as a parameter except for the password. And that's because, and this is actually very important to take note of, if you're using the ARM template, always use a secure string for passwords. Because otherwise, if I just used a normal string, it would show that right here. So my password would basically be exposed to anybody who has access to this resource group. And it looks like the deployment is actually done now. So if we take a look back at the release, we can see, all right, it's already done. Deploying the actual website. It's very quick because basically it just copies the zip file out there. So let's take a look. Let's see what we have. So back in our resource group, looks like all of the resources are out here now. I'm not going to take a lot of time to look into all of them, but the website has a browse link because Azure gave us a DNS name for it. So all I need to do is click browse and it'll open up in my web browser. The first time we start the site, it'll probably take a minute. I believe it's doing the database migration as part of the first startup. So it's deploying out the schema and sample data out to the database. So it takes a little while the first time we come to the site. And here it is. So this is the website that we deployed, eShop on Web. That's the sample from Microsoft. We have our different items that are available for purchase. I can add this red t-shirt to my basket and it got put in there. So that means that the database connection is working. And we have in the footer our version numbers. So this is version 1.0 of the website. All right, and this is our, if we look here, dev environment. So now that the stage of the release is done, I don't have Outlook open, but I got an email asking me to come in and approve the production environment. So I'm actually going to approve that now because I went to dev, it looks fine to me. So let's go ahead with it. All right, so I approved it. The other options I have are to reject it, or I can reassign it to somebody else. So if I don't, maybe I'm not in a position to, I'm sorry, I must have left the gates in here. So I guess, let me take a look at that. So the gates will normally run, you can configure them to run either before or after the approvers. Normally, it really depends on what your gate is for. If your gate is checking that the environment is in a position to accept a new deployment, then it's good for that to be after the approvers. If your gate is part of a release management solution that you have, then you really want it to be before the approvers. So multiple options there. And actually, let me just come in here and cancel this release. So we're just going to go through this quickly again because I made that mistake of keeping that enabled. So this actually brings us back to ARM templates. So ARM templates are, they'll actually compare the current state of the Azure environment to the state defined in the ARM template. So in our case, we didn't change the ARM template at all. So all it's going to do is compare the current environment to the existing environment, and it'll find that it doesn't actually need to make any changes. So it's not going to delete resources and recreate them. It's not going to do any of that. It's just going to, make any additional changes as we define them in the template. And something important to note there, and that's why it only took 33 seconds. If you delete a resource from an ARM template, that doesn't delete it from Azure. So that's something to keep in mind. All right, so now let me approve this. And now it should actually go ahead and start processing our production deployment. All right, so it's going to go through here. We'll let this go. It'll probably take a couple minutes and we don't have a ton of time left. So while this is going, I'm going to keep this here. Let's take a look at what it would look like, beginning to end if I want to, make a change to the site. So let me open up my boards in a new tab. We'll keep this going so we can take a look back at it. So I come to my board and I see, okay, let me filter it down and only look at work items assigned to me. So I already added the version number to the website, but now I need to update the version number. So if I look at this user story, I need to update the eShop website's version number in the footer to 2.0. All right, let me do that. So I'm going to start work on that right now. So I move the card over to doing in progress. And from the card, I actually have it. So the nice thing about using all the different parts of DevOps together is that they are all very well integrated into each other. So since I'm using the repos to store my Git repository, from the user story, I have the option to create a branch to get started. So I'm going to do that. So create a branch here. I'm going to put it under the features folder. And then I'm going to use the user story number, update site. So this is the name of my branch that I'm creating. And it's going to be based on the master branch. So when I click create branch, it's going to create my new branch. It brings me to repos and shows me the files in it. You can see my branch is selected up here. And it also associates this branch with that work item. So back here on the user story, now we see my branch is associated with it over in this development section. And this is very useful because it lets you really tie the user story to all of the work that was done as a part of that user story. And going forward, we'll see how it looks and how it gets tied into the deployments as well. So my next step is to come into Visual Studio, come into Team Explorer, and make sure I have that branch and switch to it. So to pull down the new branch, all I need to do is do a fetch. So that pulls all of the repository information from DevOps. Then I come to branches. It's in the features folder. Here it is right here, 324 update site version. So I'll switch to that branch. And let's check in on our release. All right, looks like the production release is done. So switching gears again, let me come back into Azure and look for my production resource group. Here it is right here. And we expect if we go to this website, we should see the same exact thing that we saw on the dev website. The only difference now is it's in the production website. That's going. I just want to make sure that my release is going to properly report deployments to the production environment. Yeah, so prod we select as production. All right, and it looks like my production site is working as well. So the power of the ARM template combined with the pipeline is that whenever I want a new environment, all I need to do is create a new stage, use the same ARM template with different parameters, and deploy the code out to that new environment. So it's a very quick process overall once you have that ARM template defined. So back at my Visual Studio. So let's change that file. So close all of this. So if I want to get to the footer, that's under the web project. Use shared layout. All right, right here. So it's version 1.0 right now. Let me change that to version 2.0. Save the file. Normally, you would want to test this locally. Let me just take a look at the changes. Just this one file. 1.0 to 2.0 looks good. All right, so update site version to 2.0. commit my changes. Now I just need to come over to sync and push that out to DevOps. All right, now that I'm done with my development, I can come into DevOps and create a pull request to get that code into the master branch. So under repos, we go down to pull requests. There's nothing here right now, but whenever we update a branch, it gives us this convenient button here for creating a pull request for that branch. And it actually pre-populates the title and description with our commit name because we only had one commit. And because we associated our branch with the user story from the beginning, it knows that that user story is associated with this pull request. So there's nothing else I really have to do here. Just ensure that it's going into master, which is what we want. Then I'll click create. All right, so this is the pull request view that's part of the Azure repos. You can see on the right-hand side the requirements. So we require at least one approver. So either myself or Gerard has to come in and click on this approve button. It needs to be linked to a work item, which it is. And it needs to be successfully built, which is running right now. So as a pull request reviewer, I can come into the files. I can take a look at what changed. If you prefer side-by-side diffs, you can change that pretty easily. You can actually come in and add a comment as well. So if I want to say, should this really be 2.0, I can come in and I can add that comment. If I want, I can tag somebody in that, so I can tag Gerard and he'll get a notification that he needs to take a look at this message and maybe answer a question. If I need to make a code change, I would come back into Visual Studio, make my change, push up a new commit, and then I can click on resolve, and then that comment, we consider that good. So we're done with that. And that's everything that's done is tracked on this main page as like a sort of log down here. And if I decide that, I want to wait for the author to make some changes and then I'll take a look at it again, I can do wait for author, in which case that blocks the pull request from being completed. If I want to, if I do reject, that's really more of, we really need to talk about this. Maybe there was a requirement missed or something like that. I would do reject. I think it looks good, so I'm going to approve it. And that lets, as we see over here, now that one reviewer approved it, and there's no merge conflicts, all we need to do is wait for the build to complete. And then our pull request is ready to be completed. So let's take a look at that and see what step it's on. All right, so still restoring NuGet packages. Like I said, sometimes that takes a while. The site probably has a ton of NuGet packages installed. But should be done with that pretty soon. Where were we? Back to pull requests. All right, so yeah, so when you come into the pull request dashboard, there's a couple tabs. You can see the ones that are either created by you or you are assigned to, but you can also see old ones. So this is nice if there's some question, oh, how did this get changed? What happened? You can always come back in here and see, oh, there was a pull request for that, and we decided to just let it through for now or something like that. The other thing you can do is if it's all approved, if you're confident the build is going to pass, you can set autocomplete. So this is what it looks like. You choose the type of merge you want to do. It has a nice diagram down here that shows what happens in Git, kind of. You can say, I want to complete my work item after merging. What that'll do is the work items that are down here, in my case, the user story, right now it's in progress. But once the merge finishes, that'll change it to done. You can also delete your feature branch after merging. Most of the time you'll want to do this because otherwise you'll just have a bunch of features, a bunch of feature branches sitting around in DevOps that you don't really need anymore. You can also customize the merge commit message. This is the one it'll use by default. really normally do that, but if you have certain messages that you want to put in there, you can do that. So I set autocomplete. Actually, it looks like it just finished. So now it's going to merge my pull request into the main branch. So the exciting thing about that is now that, let me just take a quick look at master. All right, so now that my PR is merged into master, that means, and we even see it over here, we have a build in progress. Take a look. So due to our continuous integration trigger, we now have our new build running based on my new commit to change the version to 2.0. So this is basically doing the same work that the pull request one did. It has a different purpose though, so that duplication is okay. For our case, we are, as I'm realizing, quickly running out of time. So we're going to let this run in the background, and we'll just check in on it. The next thing that we are going to look at is the YAML pipelines. So everything we've done so far is the classic visual build pipeline and release pipeline, separate from each other, but linked with the build artifact. The new way that Microsoft is recommending people start their DevOps pipeline experience is using YAML pipelines. YAML pipeline is, I have one right here. Like I said, it's a fully text-based pipeline. So this is the YAML pipeline that is basically equivalent to the two build and release pipelines that we created before. So you can do anything you can do with the classic pipelines, you can do with the YAML pipeline and vice versa. It's just a different way of doing it. So this pipeline, as you can see up here, it's in my repository. It's checked into my source code. And even if I come over here, I could open it in Visual Studio. I could, open it right through here. It's right here. You can organize it into folders. You can branch it. You can view history on it. You can do pull requests on it. All of that is in place for YAML pipelines. And that really provides some benefit because, you're treating your pipeline just as any part of your source code. It goes through pull requests, has history, and that's really useful. The other nice thing about the YAML pipelines is that you can combine the build stage and the release stages all into the same pipeline. Whether or not you want to do that depends on your process, but it is an option. So let's take a look down through this and see what options we have in the YAML pipeline. Obviously, I'm not going to go through, all of the different options you have syntax-wise, but pretty much everything we covered before is in this file. So at the top, we have the CI trigger. So you can have it trigger based off a branch, based off a certain path. In my case, I have the CI trigger disabled because I don't want this one running automatically because we created the classic pipeline for that. We decide which pool we want to run on. In our case, a Windows 2019 pool. We can set up some variables that are used across the entire pipeline. So build configuration, the path to our web project, test projects, the name of the Azure connection, the base resource name, which I've appended YAML to. So we actually have different sets of resources that'll get deployed out. And down here, we define our stages. So the first stage is the build stage. So this corresponds to our build pipeline that we created before. And each task is actually the same exact task that we used in the build pipeline, the classic one. And on top of that, you can click on this settings button and you see the same view over on the right-hand side to make changes to the properties. So this over here really bridges the gap between the fully text-based YAML and the fully visual classic pipelines. So you don't need to memorize, oh, this .NET Core CLI command has these arguments on it, and I need to memorize which ones it has. All you need to do is remember the general syntax of the YAML pipeline, or reference another one, or a documentation, and then you can come in here and say, oh, maybe I want what do I want to do? Let me let's copy file or something. Let me put a copy files in. So I can just type in my, files in here and click add. And it'll put that task in here for me with the correct syntax with all the properties. So this really makes it easier to work with the YAML pipelines, especially developing new ones. So I have all my different options in here, all my different tasks, same as the other pipeline. Copy files for the ARM template, the publish at the end to create my build artifact, and then that's it. But after that, we come into a new stage. We come into the dev stage. I'm going to pause here and take a look at my build and make sure it's done. Yep, so my eShop build succeeded. Looks like I have a release that released out to dev. So let's take a look at the dev website. So version 1.0, I'll refresh the page. When the site comes up, we should be onto version 2.0, which we are. However, I haven't done my production release yet, so when I refresh production, it's still 1.0. And that's because I have to come in here and approve this production deployment, which I just did. So once that's done, our production site will be on to version 2.0. Switching back to the YAML, now we're on our dev environment. So in this case, the releases are a little different because they target an environment. And let me open this up. So environments are something that we didn't use as part of the classic pipelines, but we do use as part of YAML. And that's because the environments are where we can define approvals for the YAML templates. So I have this eShop prod environment. And when I come into approvers and checks, you see I have myself and Gerard in here, same as I did before for the classic release pipeline. So this gives us that same functionality for someone having to approve a stage before we can, or an environment, basically. The benefit here is that if I have a production environment defined here, I can use it in multiple YAML pipelines. So I can define my approvers in a single place for that environment and reuse it across multiple pipelines. So that reuse is kind of handy there. So all I have to do here is say, eShop dev is my environment that I'm going to, and then I, have a little more syntax for the YAML, and then I just define my same deployments that I had before. So first we do the ARM template, then we do the web app. Let's see how we're doing over here. All right, so my production deployment's still going, so we'll wait on that. And then I have my production environment. It targets a different environment, but it's the same steps. And something that I don't have here, but you can do in the YAML is actually pull out different parts of the template into reusable chunks. So I could have my, eShop deployment partial, basically, and I could use it once for the production environment with certain parameters, like a different environment. And I could use it once for the dev environment. And that way I don't need to duplicate all of this code. I can just define it once and include it in this main template. So that reusability is something that's very nice as part of YAML templates that you don't get as part of the classic templates or classic releases. All right, now we're on production. Let's refresh this and make sure we get our 2.0. And I'm also going to kick off the YAML template so we can see the output of that. All right, production is now 2.0. So what we did is we successfully created a work item. We, developed against it and did all of our pull request and CI and CD to 2 environments, all in Azure DevOps. And I can actually come back to the work item now. So if I go to my boards, still filtered just down to my work items. So I have update eShop site version number. So it was closed. And when I come in here, I can see that it was deployed to the development environment as part of the eShop release 4 minutes ago. And it was deployed to the production environment, very recently in that same release. Down here under development, I can see which build it was first a part of. So that's this build here that was from the CI. I also see which pull request it's associated with and which commit it's associated with as well. So once everything in DevOps is, connected together, which it pretty much is by default, you just have to put in the effort, if it can be called that, to associate your work item to your commit. And after that, everything else kind of flows back to the work item. So next year, if I want to know, who did this, I look up here, I can see, oh, here's the pull request. Let me see who approved it. Let me see when it went out to production. Normally development and production don't go out on the same day. You can also use this if you're, in the middle of development, right? Oh, it's out in my development environment, but QA needs to hold off because it's not out in my testing environment. So that gives everybody a good insight into where every single user story is, in the process. And that's really one of the big benefits that Azure DevOps brings when you use the boards and the repos and the pipelines together. So switching back to the YAML template, the view is very similar. The only difference is down here, it has all of the stages in here instead of in the separate build and release pipelines. So you can still see all of our tests in here. We can get our code coverage out, all of that stuff. And then right after the build, we just see it move straight to dev. And you can see each environment, and actually let me show this in its own tab. Each environment also has a record of all of the deployments that were made to it. So this is another good way to audit what's gone out to each environment in your system. So, it's going to go out here. It's going to do our ARM template deployment, which it's going to new resources, so that'll take a while. It's going to do the build. We'll have the same approver check here. It's going to ask me to come in and click the approve button before it goes to production. So really, it's the same functionality as the classic pipelines. It's just kind of a cleaner way to do it. And it lets you reuse code between maybe different projects that have the same format. If they're both websites, have to do the same kind of build. And it lets you version your pipelines as part of your source code. So, this is going to go, there's nothing unexpected here. And I think we wanted to save a couple minutes for Q&A. So, all right. So back to DevOps as a whole. When you're looking to adopt DevOps, maybe not even Azure DevOps, just as an idea, as a workflow, a way of doing things. There's a couple benefits that Azure DevOps can bring to the table. When you look at cloud-hosted source code, there's a lot of benefits to that over hosting your own internally. You don't have to worry about, if you're running TFS, keeping the server up to date, keeping TFS up to date, managing the separate SQL server to keep all the stuff in, and your team project collections and all of that. So there's a lot of, and you also don't have to worry about, either having all of your developers on VPN, especially now when everyone's working remotely. Azure DevOps is authentication based on Azure AD or just Microsoft accounts. And everybody can just connect from their homes, from their computers. You don't have to have everybody VPNing into a central location in order to access source code. You can also innovate with the cloud to quickly prove out solutions. So maybe your production environment is on-prem and you're not looking to change that right now. That's a pretty big change. But maybe you want a test environment, but you don't want to have to buy new servers to support that. You can use Azure DevOps and Azure to quickly create a test environment with an ARM template. Maybe you only need it for 2 weeks in your QA cycle. So you can use your ARM template, create your environment, deploy your code out to it, and at the end of 2 weeks, delete the whole environment so you're not charged for it anymore. And next time you need it, just run your release pipeline again, and it gets created automatically. So using Azure DevOps as your tool set can really help bring all this together. And if you want to improve and automate your deployment process, DevOps really helps with that as well. Whether you're using something like Jenkins on-prem or the old TFS builds, DevOps really modernizes it and brings it all together. So at this point, we will open the floor to questions. And after that, we will put up the link for the survey. And remember, there is a $25 Starbucks gift card for one person who completes the survey. I don't know which one. I guess. So yeah, questions.
That's great, Ben. Thanks for doing that. And one thing I want to comment on is it's pretty amazing that in 90 minutes you were able to demo the pipeline and deploy the system in 2 different environments successfully. And that's testament to what you could accomplish with using a DevOps process and using the right tool set. So that was a great job there. So yeah, let's open the floor to some questions. You could either voice them in, so you come off mute if you want to ask a question, not a problem. You could chat with us in the chat pane if you know how to do that within Teams. There's a little menu that if you hover over the screen, it'll give you the ability to click on the little kind of like balloon chat. Click on that, your little chat pane will open up. You can type in there. You can raise your hand. There's a new hand feature in Teams. I'm not sure if everybody's familiar with that. You can raise your hand. It's kind of cool. So let's open it up. Give it a couple of minutes. And what we can also do in the meantime, while if anybody is formulating your questions or formulating the questions, if you don't mind, go to the next slide, Ben. You could post or view the link for our survey. There you go. And you can start the process there. And while everybody's filling out their survey, if you have any questions, you can ask during that time as well.
The link is also in the chat section in Teams if you just want to click on it.